here's my setup. We have the Nissan battery pack modules, 384 volts worth, or 388 volts. I've measured it here. It's 384, 387, whatever the right number is. They go through a significant cable that comes up under into the back area here through a master safety switch into the contactor that's controlled by the by the Thunderstruck VCU, and all the wires like this for the can and the pedal and all the brake, they're all set up. Here's the serial for GTY. When power is engaged with the contactor, these cables power the inverter, which is in the engine bay. You see here pairs for the Chatamo J772 and the full 385 volts, whatever that number is. Right now I have the PDU physically removed, so we're going power right into the inverter. And I'll talk about this in a moment. This one is 12 volts all the time, and this one is 12 volts when the key is switched. They are powered not by a battery at the moment, but rather a decent lab power source, set for 13 volts, max 3.4 amps, and everything is off. I set it for 3.4 amps because I don't want any surprises, and I do not exceed 2 amps. Let's talk a little bit about the CANbus infrastructure, and then we'll talk about the connector over here. So we have the CANbus coming out of the inverter up through here, blah blah blah, comes out to this useful Wago connector. One pair goes to the Thunderstruck controller, one pair goes back to the inverter, and another pair goes to this very useful Raspberry Pi on the side. On the Raspberry Pi, I have set up CANDUMP any, can sniffer, so we'll see unique messages here. We'll see all the messages there. And on my laptop, through the TTY connection, I am connected to the Thunderstruck controller. Right now, everything is off. Let's talk about the ugly details of the inverter. So, per the wiring diagram, pin 42 is the ignition switch. This goes, the yellow line goes out to the battery when, not the battery, it goes to the key block. When power is on, this is live, otherwise it wouldn't be. All right, these two were marked as 12 volt. These two were marked as ground, and the remaining bundle is untouched. That is going to the resolver. I've checked that the resolver is fully seated, and that is good. I have disconnected all the other wires that go to the PDU. I have Wago connectors, so I can come back to that because I want the PDU in here. At this moment, I have put 12 volt LEDs on the ignition switch, as well as a 12 volt full-time supply. So when I power this up, you will see that the ignition switch does get powered, as does the 12 volt. I also have LEDs in the battery block and in the key block so that we can see that they are powered when I power up the system. A good fundamental test would be what happens when we put power into the system. So I will turn on the 12 volt subsystem first. We'll hear the VCU activate the contactor. We'll hear clickiness, and we'll see the voltmeter go to 380 some odd volts. Actually, I will power the 12 volt system first. You'll see the lights illuminate. You'll see that the key switch, it will be off. Then I will activate the key, which will activate the contactor, and then we'll see happiness here. All right, so let's do that. Okay, everything's idle. We're drawing 0.5 amp. You see the battery block is illuminated. It's got power. you see that this LED indicates that there's 12 volts going into the common 12 volt signal into the inverter. Now let's activate the key switch. You heard the VCU go active. You see that it's blinking green. I think that means goodness, I think. Coming back to the voltmeter, we see it's at 385-ish, and we're drawing 1.8 amps. That all sounds really good. Let's repeat that now watching the TTY port, as well as watching the CANDUMP and the CAN sniffer when I power up the 12 volt system. The key is on right now, so these will go live. I'm gonna click the output power and you'll hear the contactor engage in the background, and I will pan between the screens. I'm gonna leave it on CANDUMP any at the moment so that we can see that the inverter starts talking right away. Boom, all goodness there. We see that the inverter is talking. It's probably complaining about an error message. Over here on the Thunderstruck, it looks happy. Let's do a trace CAN. So it's seeing CAN data, that's good. Let's do a trace of the user control. Okay, goodness here is that we're seeing it recognize the voltage coming from the 1DA packets. It's correctly saying there's no RPM, there's no torque being applied, and I'm going to pause this video, go over to the gas pedal, and throttle it while this is recording. Here I'm going to do a trace for the CAN and the user controls, a quick review of the configuration. Something that might be interesting, it's set for Leaf Inverter. The FNR switch is enabled, CAN termination is enabled. That's obvious, we're getting CAN messages. It says the VCU is happily running, and brake is off. I've toggled the brake, that works well, yay. FNR is set for forward. A question I have is, I have it wired for forward always. Do I really need to make that a switch? Didn't seem like that was a requirement. Leaf message, it's like it's getting the 1DA stuff. It's getting the voltage correctly from the voltage from the 1DA matches voltage I measured through DVM. And I'm going to start the trace, walk over and press the pedal, cycle it a little bit. You should see the scrolling of the percent, and you'll also see there's no messages going out to the inverter. All right, let's begin. Trace UC, okay. I'm going to work the pedal now. You should see some changing in the percentage. I'm just lightly pressing it. I'm hearing nothing from the motor. All right, and I'm going to walk back to the camera. Just for sanity's sake, let's do a walkthrough on the pinout. 42 light green ignition switch, 42 light green ignition switch. We see we have an LED on here, so I know when it's powered. It is activated right now. This goes to the battery, the key block. Pins 47 and 49, which are both black, should go to ground. So that's these two bottom pins down here. Black goes to the Wago. The Wago has a black that goes to the key block ground. Similarly, let's talk about the 12 volt. So VB2, VB1 should be green, pins 46, 48, tied to 12, to green, 46, 48, go to the Waco. They also have an LED for sanity, and the 12 volt supply from the hot battery box. All right, pins 14, 15, CAN high and low. We're getting CAN messages. I can send CAN messages to the inverter. It responds, so we know the CAN bus is working. I have measured that there are 60 ohms total on the line when there is no active power. I have a 120 ohm resistor just out of view on the back side of that Waco connector. So that part's been checked and confirmed and happy. And this bunch of cables that's wire wrapped, that is the resolver. The resolver also had 2 gray lines that go to the PDM. I have just Waco'd them. Maybe that's what's not right. Maybe one of these or both of these should be grounded or tied high, or I'm asking for help. I want to verify that I can send CAN messages to the inverter, and that the inverter intelligently recognizes it and responds to it. So I'll send 784, which is an inverter query, and over here we'll see when I power up the system, the 1DA, the 55A, and we'll see the 784 and the reply from the inverter. So I'm powering up the system. Okay, and I'll do this. So we're seeing over here the 1DA, 55A, all is happy there. Send, and we have the sent and reply message.